Hello and welcome to Mod 12.4, Predictions with Experimental Probability. Our goal is to use experimental probability to make predictions. And so once you see a couple of problems, I think you'll see where this is going. Now, the big way we go about this, the how-to, can be boiled down to one word, and that is proportions. We're going to be using a lot of proportions to solve these problems. So what's going to happen is in proportions, there's two ratios, fractions set equal to each other. On one side, we're going to have a smaller sample set. All right, and so what we'll have is the number of times something happened over the total number of times it happened in that sample set. Then on the other side, we're going to have this is the prediction side. So prediction. And what we're going to have here is the bigger total of times something is going to happen. And up here in the numerator is going to be the prediction. And so that's what this is usually what we're going to be solving for is the prediction. Or sometimes we might be looking at a prediction and the question is, is that an accurate prediction? Is that a reasonable prediction? But what it boils down to is a simple proportion. And so let's look at an example and try to make light of that. Okay, this is the first one. My art's a little crude here, but let's say you have a 20% chance or experimental probability of hitting a bullseye while playing darts. So you throw a little dart at a dartboard, and 20% of the time you've gotten a bullseye. Now, and this is just 20%. We don't know how many times you've done this. I mean, maybe you've done it 5 times, 10 times, 20, 100. I don't know. But the question I'm going to ask you is, how many bullseyes would you get out of 75 throws? How many bullseyes would you get out of 75 throws? So what we'll do is we'll take our number 20% and we'll make that a fraction. We can go 20 over 100 if we want. We could reduce that if we want to all the way down to like 1/5. So we'll take either one of those. And for the sake of kind of keeping things easier, I'll use smaller numbers. I'll use 1/5 is equal to x over 75. All right, so again, 20% is the same as 1/5. I could easily put 20 over 100, just bigger numbers. And now I'm going to use cross multiplication to solve for x. And so I'll have 5x is equal to 75. Divide both sides by 5. And x equals 15. So you could expect 15 bullseyes if you were to throw a dart 75 times based off of this probability, experimental probability right there. So let's take a look at a few more examples to see what we can get from them. So this one, very similar to the example we just looked at, just slightly different. A car rental company sells accident insurance to 24% of its customers. Out of 550 customers, how many customers are predicted to purchase the insurance? So what we'll have to do is take that 24%, make it 24 over 100. This time, let's just leave it as is, over x over 550. All right, and so again, this is our new total. That's the big number we're going with, and this is going to be the prediction, the number we're looking to find. Do some cross multiplication, so we'll have 100x is equal to 24 times 550, which is 13,200. Big number, looks a little alarming, but it's okay, because we're going to divide by, divide by 100, divide by 100, and what we end up getting is x is equal to 132. So 132 customers will purchase insurance based off of that experimental probability. And we can do a quick dot check just to make sure everything makes sense. 130 out of 550, that seems to make sense. It's not like we are talking about 1,320 out of 550. That wouldn't make any sense. So that number looks good to me. Oops. All right. Let's look at another example here. So here now we're going to be adjusting the question that's going to be asked, but the process remains the same. A doctor's office records data and concludes that, on average, 11% of patients call to reschedule their appointments per week. An office manager predicts that 23 appointments will be rescheduled out of 240 appointments during next week. Explain whether the prediction is reasonable. And so we got a lot of wiggle room here because that word reasonable is very open-ended, but let's just see what the raw math tells us. 11 over 100, that's 11%, is equal to x over 240. Do some cross multiplication. 100x is equal to 11 times 240, which is 2,640. Divide by 100, divide by 100, and x should equal 26.4. So now that's what the raw numbers tell us. And what we got to think about now is, how does that relate to that 23? And so here, depending on how, I don't know how strict of a person you are in terms of things and like what your definition of reasonable is, I think you may say it's reasonable or it's unreasonable. I would say out of 240 total appointments, you're off by about 3.4. I would say overall that this is fairly reasonable. So it's not that bad of a guess that 23 of them will be rescheduled. However, maybe add in, it's a little low. But overall, yeah, it's reasonable. Let's take a look at one more example. Okay, so in this one, again, we're going to have to find the prediction and then kind of do some sort of comparison with it. An online poll for a movie site shows its polling results for a new movie. If a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on the online poll? Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? Okay, so we got a lot we have to do here. As it says here, we're definitely analyzing some information. Okay, so first of all, let's see. How many people can it predict will like the movie? So, did you like the movie? Yes. That's 72%. 72 over 100 is equal to x over 150. Okay. Again, do our little cross multiplication. We'll get 100x is equal to 72 times 50, which is 10,800. Okay. Divide by 100, divide by 100, and then here we're going to get x equals 108 people. Okay, so that's if everything goes perfect in a perfect world. 108 people should like this movie. So that's the answer to this first part here. How many people can it predict based on the online poll? 108 people. That second question. Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? For that one, I would say yes, because again, we're just off by 4 people. That's not too many. And so, it depends on what showing you go to. Depends, how many people went along with their friends. Maybe didn't really want to see the movie, but they wanted to hang out with their friends. It depends. Is this opening night? Is this 2 weeks after opening night? So there's all kinds of variables, but to only be within 4, or to be within 4 of the claim, I'd say that makes it pretty accurate there. So anyways, that's what you're doing today. You are taking a look at some information. You make a proportion like we've been doing right here. You've solved the proportion, and then maybe you might have to ask some follow-up questions about that proportion. But as long as you make the proportion, you should be good to go. Again, don't hesitate to reach out if you have any questions, and good luck with your homework.